Hello folks, I'm Alex and welcome back to my channel. This part 2 of the video that is devoted to Meadow Hack Kit Pro and IoT. As mentioned in the previous part, and the link can be found below, I will be assembling the board, pairing it with my laptop and installing the updated firmware so we can start developing a hardware part as well as the software application that will be deployed to this device. If you are interested in more content like this, please leave your comments below, like the video and hit subscribe button so you can get notified about the new videos. Without further ado, let's get started. To complete this step, you need the following: one Meadow board, one wooden wilderness slabs proto board, 2 female header pins, 4 screws, 8 nuts, and this is basically all this. Out of the box, the baseboard comes with a protective skin cover to protect the surface from dents and scratches. If you already peeled the skin cover from it, we can start with the next step. In other words, soldering Meadow header pins. For this step, all you need is a pair of blue header pins and F7 Meadow board. Before we begin though, let's talk about the tools we would require. You need a soldering iron, but only this time, as assembling a fully functional prototype won't require soldering as such. Any soldering iron would do. I've got a relatively cheap here, and the benefits of this one is this adjustable temperature knob. This is something you can buy on Amazon, and I will leave the link below in case if you need one as well. Some people also use soldering fume extractor, and even though it's not that expensive, just to make sure you don't inhale toxin fumes, make sure you do the soldering in the properly ventilated room. Next, soldering iron tip cleaner. Once again, to keep the expenses low, you can simply use a stainless steel sponge that can be purchased in a dollar shop, or a piece of sponge comes with the soldering iron kit, just like this one in my case. To prepare it, it's enough to soak it with water. Having a lead-free solder is important, so it's not toxic. Soldering flux paste is not mandatory, but if you solder a lot, you can get something like this one. And a heat-resistant surface to protect the table is a must. You can simply use a piece of plywood or a silicone mat like this one here. They are pretty cheap, but if you don't solder a lot and this is only one-time enterprise for you, no need to invest. To start, let's set the soldering iron temperature around 350 centigrade or 650 degrees Fahrenheit. Higher temperature is risky as you can damage components on the board. You can raise it as you get better at this. Once the soldering iron is warmed up, clean and thin the tip. Next, we need to place our components in place like this. Simply put the blue header pins through the holes. Let's apply some soldering flux using a watercolor brush. This on flux and apply to the pins on the other end. This technique makes soldering a lot faster and smoother, and there is less of a chance of overheating the components that are temperature sensitive. So make sure there is enough solder to fill in the hole and leave a little pyramid mound, but not so much. So it looks like this. Soldering, guys, deserves a separate video, and there are plenty available on the internet. I'm not gonna stop here for too long. Now I will simply fast forward the video and show you the final result. Alright, so this is the final result, guys, and this is done pretty neat, and all I need to do now is just to clean up the board. So to clean the board, use some rubbing alcohol and a sponge in order to clean the leftovers. In this step, we'll assemble the board and make it ready for prototyping. Make sure the board is properly positioned. Find the battery connector over here on the middle board and the orientation of the breadboard that will be positioned over here. So let's put each screw in the corners of the middle board with one nut like this. So placing it like this is important, so the base won't get in contact with the wooden board. Next, let's fix the middle board through the proto board and use the remaining 4 nuts to hold them together firmly. In addition, you can get metal fasteners and screw them to the corners of the baseboard so it can sit flat on any surface. The fasteners are not included with the kit. However, if you assemble computers often, you might have some spare part like this, and as well as screws. I have prepared 4 of which, and let's attach them to the board. Next, we will be deploying Meadow operating system. All the steps below are only applicable to Windows system. If you work with Mac OS X or Linux, please use the links below to the video to find respective commands for your operating system. When you start working with Meadow board, it will need to have the latest Meadow OS flashed to it. Prerequisites for Windows are simple. So first you need to check install .NET SDK, and doing so is very simple. .NET list SDKs. If you have any SDKs installed to your system, this command will list those. If you don't have the latest SDK installed, all you need to do is just to go to the official Microsoft website and download the SDK applicable to your operating system. Next, we gonna need to update USB driver for ST devices. To flash Meadow OS, DFU util is required. However, the default Windows USB driver for ST devices is not compatible with DFU util, so it needs to be replaced. To achieve this, we can use a tool called Zadig. You can download and run this tool using the link I placed under the video. I have already downloaded one, and all you should do here is click list all devices to find STM32 bootloader. It's not listed here just because the board is not in bootloader mode right now. So in order to place it in bootloader mode, please do the following. Hold the boot button, then press and release the RST or Z button, then release boot button. You will discover that the new device has appeared in the list, and in driver section it says there is none. So instead of replacing driver, you need to install one. So just click install. The final result should look like this. Next, we need to install or update Meadow CLI and DFU util. So I'm gonna use a snippet here. .NET tool install Wilderness Labs Meadow CLI -global. And as you can see, it has been successfully installed. And now we need to install a DFU util. All done. Next step, we need to download operating system and network binaries. So to do so, just use the following command: Meadow download OS. It all depends on the speed of the internet on your computer, and now we are ready to flash it. Meadow flash OS. Okay, Meadow OS has been deployed, so what's next? Let's see what CLI is capable of. Meadow device info. And this is something that is expected. So the CLI needs to know how to connect to a device we just updated. To do so, you need to figure which port it needs to connect to. And during the update, you saw that it was trying to connect to COM4 port. And this is something you can see in Device Manager as well. If you take a look at ports COM and LPT, you will discover that the USB serial device is connected to COM4 port. So in order to bind device to this port, let's use the following command: Meadow use port COM4. All done. And if we use this command once again, I'll be able to see the information about device, device name, and the firmware version. So next step would be preparing our Visual Studio environment, and for that we need to install an extension. I've got a Visual Studio 2022 installed, just recently updated, and over here you can click continue without code, select extensions, manage extensions, make sure you've got online selected here, and just search for Meadow, and you'll see there is an extension available that is called Visual Studio 2022 Tools for Meadow. The version for 2019 is also available. And just to complete the installation, we need to close Visual Studio. Okay, once done, we can open up Visual Studio once again. And over here, if you are to create a new project, you should be able to see Meadow application. Okay guys, we are pretty much done with prerequisites here. In the next video, we'll start assembling our prototype, which is the temperature monitor, as well as develop and deploy the application and see it working all together. See you in the next episode.